Okay. Question B. The wave number of electromagnetic wave propagating through a conductor can be written as K equals to Kr plus iota Ki. Okay, so Kr plus iota Ki. Okay, so here Kr is the real part and Ki is the imaginary part. Kr is basically called the propagation constant. Okay, and Ki is called attenuation constant. So Kr and Ki is given here. The expression of Kr and Ki is given here. Then we have to show the skin depth for good conductor and bad conductor. Okay, fine. So for good conductor and bad conductor, we have to know the ratio of conduction current density, also the um, uh, displacement current density. Okay, uh, before that we have to know the expression of skin depth. Okay, so basically skin depth is defined as delta, and it is mentioned as reciprocal of this Ki. Okay, reciprocal of this attenuation constant, 1 by Ki. Okay, so now for good conductor, question 1. For good conductor, for good conductor the ratio of Jc by Jd, that is basically sigma by epsilon omega, is very higher than 1. Okay, so using this condition we can derive the Kr and Ki. So Kr basically omega root over mu epsilon divided by 2 times this is root under 1 plus sigma by epsilon omega whole square, then plus 1, then to the power half. Okay, so since sigma by epsilon omega is very higher than 1, so we can rewrite this in terms of omega times root over mu epsilon by 2, then sigma by epsilon omega to the power square, then root, so we get only this sigma by epsilon omega, then again 1 by 2, that is squared. So this will be squared. So from here we get uh, root under um, root under uh, what we get, epsilon are cancelled out, both are under root, then we get mu sigma omega by 2. So this is the Kr value. Okay, so this is the real part of the K, and similarly we can derive the Ki value. So Ki will be again omega root over mu epsilon by 2, then here root under 1 plus sigma by epsilon omega whole square minus 1. Similar way we can derive this, that is Ki basically root under mu sigma omega by 2. Okay, so this Kr is called propagation constant, and this Ki is called attenuation constant. Okay, now Kr and Ki both are same. So here skin depth is defined as basically reciprocal of Ki. So since Ki and K are same, therefore we get 1 by Kr. Now here Kr is the propagation constant, so propagation constant is defined as twice pi by lambda. So twice pi by lambda, that is the wavelength of the EM wave. Okay, so therefore we get for good conductor we get the skin depth is nothing but lambda by 2 pi. Okay, for good conductor skin depth is nothing but lambda by 2 pi. Similarly we can show for bad conductor. Okay, so this is the question number 2. So for bad conductor, so now we can remove this part. So for bad conductor we can write kr for bad conductor, sigma by epsilon having some value. Okay, so we find only ki for bad conductor. So ki is nothing but omega root over mu epsilon divided by 2 into this term inside, that is root under 1 plus sigma by epsilon omega whole square, then minus 1 half. So we can expand this term. Basically this is nothing but 1 plus sigma by epsilon omega whole square, okay, to the power half. So since it is for not bad conductor, it is for poor conductor. Okay, so it is for poor conductor, sorry for mistake. Okay, so for poor conductor sigma by epsilon omega is less than 1 but smaller than 1. Okay, so we can expand this by binomial expansion, and since sigma by epsilon is small, so we can take only the first order term here. So here we get 1 plus 1 divided by 2 into sigma by epsilon omega whole square. So this is the first order term. So we can replace this using this value here. So from here we get ki equals to omega root over mu epsilon by 2, omega root over mu epsilon by 2, okay, and then this into 1 plus 2 divided by sigma by epsilon omega whole square, then minus 1 to the power half. So from here omega root over mu epsilon by 2 into 1 cancel out, then 1 by root 2 here, then this is sigma by epsilon omega. So from here we can cancel omega and omega here, then we get sigma by 2 into root over here we get sigma by epsilon. So this is the value of ki, imaginary part of k. Now the skin depth is defined for poor conductor or for any conductor, that is delta equals to 1 by ki. So here ki is this value. So delta for poor conductor will be 2 divided by sigma times root over epsilon by mu. So this is the skin depth for poor conductor, and this one the skin depth for good conductor. This is for good conductor, and this is for poor conductor. Okay, so this is the answer. So here the conductivity of a metal is given as 5.8 times 10 to the power 7 ohm per meter in meter. Okay, then find the attenuation of an electromagnetic wave of frequency 1 kilohertz. So f is given as 1 kilohertz by a plate of thickness d is given 0.1 meter made of metal. So since it is metal, so it will be a good conductor. Now we get for metal conductor, for good conductor, that is the ki value, attenuation constant, is defined as root under mu epsilon omega by 2, sorry, mu sigma omega by 2. Okay, so sigma is here given, omega is basically twice pi f. Okay, so twice pi into 10 to the power 3, this is rad per second. Okay, and also mu is basically for all metals mu almost equivalent to mu naught, that is 4 pi into 10 to the power minus 7. So for ki it will be 4 pi 10 to the power minus 7, okay, times sigma, that is 5.8 into 10 to the power 7 into twice pi into 10 to the power 3 divided by 2. So as a whole we get 2 and 2 are cancelled, then pi square out will be 2 pi, here 4, so 4 pi square out, 10 to the power minus 7, 10 to the power minus 7 are cancelled, then 5.8, so here 2 it will be, so 5.8, so 10 to the power 2, then 10 out of the root, then inside the root we will get 58. So here the answer is 20 pi into root 58. So what will be the value of this? So 20 pi into root under 58. So this is almost 578 point. Basically it is almost 4.7 into 10 to the power what, into 10 to the power I think 2. Okay, so this is the Ki. Now we have to find the attenuation of the electromagnetic wave. Okay, now here K equals basically Kr plus iota Ki. Okay, so if we consider the expression of E field is this, e to the power iota K dot R minus omega t, then if we replace this here, then we get a term here that is E naught into e to the power minus, basically it is Ki times, if we consider the wave is propagating along the z direction, so kz, this will be kz, so ki kz into some exponential factor, phase factor. Okay, so this is basically the amplitude term, okay, of what, of damped wave. Okay, so this term e to the power minus iota ki, sorry, minus ki into z is called the amplitude of the attenuation. Okay, so how much the wave is attenuated, this value gives that sense. Okay, so attenuation will be, so the attenuation is basically e to the power minus ki into d, so d is the thickness of the metal, so it will be exponential of minus ki is 4.7 into 10 to the power 2 into d is 0.1. okay, so what will be the value, so here we get only 10, then it will be minus 0.47, so exponential of minus 0.47. okay, so we get 0.63 almost. Okay, so this is the 0.63, I think it will be meter. Okay, so sorry, so this will be unitless, so this, since it is exponential, okay, unitless, so 0.63 is answer. So this is the attenuation of the electromagnetic wave. Okay, so thanks for watching.